Welcome students in School of Scholars. Now we are going to start today Sn1 and Sn2 mechanism. This is very important topic belonging to 12th class chemistry. This question can be asked in exam for 5 marks. Now Sn1 and Sn2 are two mechanisms which deals with the substitution nucleophilic reaction, and 1 and 2 represents the order of reaction, means substitution nucleophilic unimolecular and substitution nucleophilic bimolecular. Now we'll see one by one. First of all, we see Sn1 mechanism, and after that we'll see Sn2 mechanism. Now Sn1 means substitution N for nucleophilic and 1 for unimolecular. Unimolecular means substitution nucleophilic unimolecular. Now the substitution reaction in which a weaker nucleophile replace a stronger nucleophile is called a nucleophilic substitution reaction. For example, we have Rx. Rx means alkyl halide. Now here we are discussing about nucleophile. Nucleophile will take nucleophile as Nu negative. In the previous lectures we have seen nucleophile is negatively charged species having a lone pair of electron. Okay, now what will happen, this nucleophile will substitute the X. Okay, X is also a nucleophile. Okay, but here X is connected to R group. Now what happens, it gives R N U plus X negative. Okay, this is nucleophilic substitution reaction. Substitution reaction which is occurred due to nucleophile. This nucleophile is substituting the X and taking the position of X. So this is a substitution reaction. Now the well-known example of substitution reaction is tertiary butyl bromide. Okay, this is tertiary butyl bromide, and the nucleophile is hydroxyl ion OH negative, and this is a nucleophilic substitution reaction. That's why we are writing SN reaction. Okay, or substitution nucleophilic. Then what happens, this nucleophile hydroxyl ion will substitute the bromine. Bromine is nothing but bromine is X. X means halogen. Now what we will get, CH3 by 3 COH. This is tertiary butyl bromide, and after the attack of nucleophile, that is hydroxyl ion, this tertiary butyl bromide is converted into tertiary butyl alcohol. Okay, this is tertiary butyl alcohol. Now, how this reaction is going on, this we will see in mechanism. Now, mechanism of Sn1 reaction. Sn1 reaction, just now I have told you the uh, tertiary butyl bromide is converting into tertiary butyl alcohol. Now, this reaction is also called as base hydrolysis of tertiary butyl bromide. Okay, or we can also say that alkaline hydrolysis of tertiary butyl bromide. Now we'll see the example, actually what's going on. Now this is tertiary butyl bromide. This is the formula, structural formula. Okay, this is tertiary butyl bromide. Okay, this is tertiary carbon and this is bromine. Okay, now we have KOH, potassium hydroxide solution. Okay, tertiary butyl bromide and potassium hydroxide solution. Potassium hydroxide solution will give hydroxyl ion, and this hydroxyl ion replaces the halogen, means this hydroxyl ion will replace Br negative. Now what happened? This is tertiary butyl group. This is tertiary butyl group. Br is substituted by OH group. Then here OH group, this Br and this potassium will form KBr. Okay, so this is Sn1 reaction, but this reaction is Sn1 reaction, but this reaction is taking place in the steps, and we will study these steps in detail. Now in this reaction, what happened? The reaction is going on, but the rate of chemical reaction, rate means speed or velocity, rate of chemical reaction or velocity or speed of chemical reaction, speed of the alkaline hydrolysis of tertiary butyl bromide is only dependent on the concentration of tertiary butyl bromide, that is a substrate. Means what we can say, rate is directly proportional to the concentration of tertiary butyl bromide. Okay, in this reaction, the rate of reaction, velocity of reaction is directly proportional to the concentration of tertiary butyl bromide. Okay, now rate of reaction depends upon only on the concentration of one reactant, then we will say unimolecular. What we will say? Unimolecular. लेकिन अगर velocity और rate, केमिकल रिएक्शन का रेट दो सब्सटेंस के ऊपर डिपेंड करता है, तो वो बायोमोलिकुलर हो जाएगा. Sn2 में ऐसे ही देखेंगे हम. Sn2 में क्या होगा? न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन का रेट दो रिएक्टेंट्स के ऊपर डिपेंड करेगा. इसे हम कहते हैं ऑर्डर ऑफ रिएक्शन. ऑर्डर ऑफ रिएक्शन हम डिटेल स्टडी करेंगे केमिकल काइनेटिक्स में. ओके, लेकिन केमिकल काइनेटिक्स में जब हम स्टडी करेंगे वो तो फ्यूचर की बात है, लेकिन अभी मैं आपको इतना समझा देता हूँ कि ऑर्डर ऑफ रिएक्शन जो होती है ये एक प्रैक्टिकल क्वांटिटी है, ये थ्योरेटिकल क्वांटिटी नहीं है जो एक्सपेरिमेंट करने के बाद में ही मालूम होती है। इसलिए हम नहीं बोल सकते कि ऑर्डर ऑफ रिएक्शन कितना होगा, ओके, क्योंकि ये प्रैक्टिकल क्वांटिटी है, प्रैक्टिकल करने के बाद में ही आपको ये मालूम पड़ेगी, ओके। अगर मॉलिक्यूलरिटी मालूम करना है केमिकल रिएक्शन की तो हम मॉलिक्यूलरिटी बता सकते हैं कि यहाँ पे 2 मॉलिक्यूल है तो मॉलिक्यूलरिटी 2 हो गई, 3 रिएक्टेंट है तो मॉलिक्यूलरिटी 3 हो गई, ओके। दिस इज